Okay, hello, Mr. Domengie, and welcome to our CIOE live stream. And today, could you introduce your company, Yole Group?
Yes, so first of all, thanks for your welcome. I'm glad to be here.
Mm.
So our company, Yole Group, is a market research company in the field of semiconductors, and we monitor many technology and devices, for example, imaging, photonics, that are the main topics of CIOE, but also processors, memories, semiconductor manufacturing, packaging, etc. We produce yearly reports on various topics, and we assess market trends, applications, technologies, and ecosystem in-depth analysis. We also have an internal laboratory, and we perform a reverse engineering, costing, and teardown of modules, for example, from smartphones, from consumer products, from automotive modules, and we also estimate the cost of these devices. We also have monitors that are monitoring at short term of the semiconductor industry on a quarterly basis, and teardown tracks where we assess the technological value evolution of many modules containing semiconductor devices. For example, what we do in our laboratory, we dismantle light detection and ranging modules that you can find in cars in China, in Luxid or Hato. And what we find inside is many semiconductor devices. For example, as you can see here, a SPAD sensor from Sony, a multi-junction VCSEL from Lumentum, and a couple of processors, one from Lattice Semiconductor on FPGA to monitor high-level processing of LiDARs, and another processor from TI for higher level processing as well, an SoC. And all of that, we estimated the costs at $200, which is rather reasonable for these modules. And it's manufactured by Huawei, who has become a leader also in this industry. This is an example of what we're monitoring.
Okay, well, can you tell us more about the events Yole is co-organizing at CIOE?
Yes, sure. Every year, we co-organize with CIOE events, can be forums, technology forums, market briefings, and also demos. We perform introduction talks to deliver to the audience the latest updates of the industry. And we also invite on the stage talented speakers from our network so they can share their vision with the audience. This afternoon, we'll have a forum on infrared imaging. So I invite you to attend this forum. It will happen in hall number 8. And tomorrow morning, we'll have a market briefing on photonics technologies, and it will happen in hall number 11. So you are all welcome to attend this forum and discuss with us and the speakers to exchange your views on these topics.
Yeah, we'll look forward to it. And what do you define as the infrared imaging in Yole, and what are these thermal cameras sensing?
Yes, interesting. So as we will see this afternoon in the forum, so today most of the applications are focusing on visible spectrum. So it means a lot of application you can find in cameras in smartphones, in security cameras, in medical, defense, or industrial applications. Then we can move to the near infrared, and it's quite popular for sensing, for example, biometrics, 3D sensing, or robotics navigation. Biometrics, like you can find, for example, in a module of Face ID in Apple iPhones, it's using near infrared. And there is a trend to use shortwave infrared, which is already popular for many applications: wafer inspection, plastic sorting, laser target designation for defense. If we go even further in mid-wave or long-wave infrared, you will find all the legacy application related to defense, thermography, fire detection, wildlife observation, and also a growing application in the field of automotives for car safety.
Well, which sensing technologies and materials do we need for infrared sensing?
Yes, interesting question. So as we will see this afternoon, there are plenty of technologies. First of all, the CMOS-based technologies are really pretty well adapted to monitor the visible and the near-infrared region. So you know, silicon is the most popular material in the semiconductor industry, and is sensitive to the visible and near-infrared light. From near-infrared, it's starting to lose its sensitivity, so you have to do engineering of the silicon surface, as you can see here, for optimization. But from the shortwave infrared, which is not visible by the human eye, and it's higher in the wavelengths, silicon is not sensitive anymore, and you have to find new materials. So there is a growing intensity in the research of new materials, for example, quantum dots. And we also have a talk this afternoon to discuss about these trends. So near infrared and short-wave infrared, they are based on reflective imaging. If you go to mid-wave or long-wave infrared, it's based on emission sensing, what we call thermal imaging. And for this application, you need new materials, compound materials beyond silicon, which are 3,5 or 2,6 compound semiconductor materials. And it needs also some specific cooling. And we have also another type of device based on MEMS technology that we call microbolometers. And this afternoon, we'll have also leading company discussing this technology on the stage.
Well, let's talk about a broader scope of photonics technologies. What's your classification of photonic in Yole?
Yes. So in Yole, we cover the broad spectrum of photonics applications. So as you can see here from the bottom, we provide expertise on many semiconductor materials. So based on silicon first, so silicon derivatives, silicon nitride, silicon oxides, compound materials as well, like gallium nitride, indium phosphide, emerging materials like lithium niobate, for example, for datacom. And we go up to the component level. So we assess either active or passive components, can be lasers, photonics integrated circuits, sensors. And after we go to the next level, which is the module. And the module, we monitor many applications like display modules, 3D cameras, LiDARs, optical transceivers, biosensors, and for example, even emerging modules like QKD, that stands for Quantum Key Distribution Module for quantum cryptography as well.
Well, that's awesome. And so we go for the final question. What will be the future of the photonics datacom market?
Yeah, so datacom is definitely a thriving domain we monitor within the field of photonics. And it's crucial in this application to assess this different distance range. So we start from the short reach, as you can see here at the bottom, like chip-to-chip interconnect through the intra-rack, leaf spines, and spine core configurations. And for example, we found different laser technologies such as VCSELs or continuous wave DFB lasers. We monitor two main trends as well related to optical transceivers that are really at the heart of interconnect and switches. The first one is, for example, as you can see on the top, linear drive pluggable optics that consist in providing transceivers, removing power-hungry elements such as DSP. We follow the trends for co-packaged optics that is becoming popular for leaf spine configurations, and go further into the miniaturization and lower power trends as well. In this field, silicon photonics is taking an increasing and major role, mainly in leaf spine configuration, but extended to other domains. We also see the emergence of new materials to provide a higher efficiency in electro-optical modulation. So there is a lot of innovation in materials we do monitors, like lithium niobate or biome titanite oxide as well. And silicon photonics also, we expect it will play a major role here on the left at the short range for optical IOs, for chip-to-chip interconnects. And we expect new products to be released by 2028.
Okay, well, thank you. Thank you, Mr. Domengie, for your sharing. And I bet everyone in our audiences can gain more information in our area, also in the Yole Group. Thank you.
Thank you.